Now, if you remember when you were trying to simulate your circuit in Model Sim, you had to provide the input stimulus for all the inputs, right? So you were giving, let's say you had three inputs, you gave three different clock signals for for all the three inputs at different clock frequencies and at different clock rates. But the problem was it's very easy to miss a combination. And the second problem is that you have to manually look for the combinations in your waveform, which can be very difficult. A good way to overcome this problem is to use test benches. So the way you start a test bench is you write library IEEE, use, remember we are taking the same circuit, write your entity for the test bench. I'm going to name my entity as TB underscore function. Your test bench has no specific inputs or outputs, so you do not include any ports. It is just a test bench where you can give different stimulus and test your original circuit. So you have your entity TB func is end. And then the next step is to write the architecture. Architecture test bench. So instead of test bench, you can give a completely different name. That's fine. Of TB underscore func is. Remember, TB underscore func should be the same name as entity. Now, if you remember, in the previous lecture, we have seen how to write the entity for the Boolean expression or the Boolean circuit given here, or the logic circuit given here. So take that entity and copy paste it. However, remove entity and put component my underscore circuit port A comma B comma C in std underscore logic and F out std underscore logic. Then write end component semicolon. So this is just like declaring your function in your program. So in C program, let's say you're trying to call a function from main. You make sure that you declare the function in main so that main knows that there is a function called XYZ in your program. So this is very similar to that. So this can be treated like function declaration. Next, we include a list of signals. Signal A, B, C, and F. std underscore logic. Then the keyword begin. UUT or unit under test. You can give it any other name. The typical names that you will see are DUT or UUT. DUT stands for design under test. UUT stands for unit under test. Call your original entity or your original function, my circuit, and you have to port map the signals that were declared here to your original circuit. So A, B, C, F. The next step is we write inputs, process. Process is a keyword. Here DUT and inputs are the tags. So they can be anything, that's fine. But process is a keyword. After process, you write begin. Here, you can specify the values for A, B, and C explicitly. So in the first case, I give A0, B0, and C0. And then I say, wait for 10 nanoseconds. So the initial values for A, B, and C will be 0, and the values will be held for 10 nanoseconds. After 10 nanoseconds, I can change my input stimulus where I modify C to be 1. Then I say hold that value for 10 nanoseconds. Then I can write A equals 0, B equals to 1, and C equals to 0. So you can go for all 8 combinations and wait for 10 nanoseconds, and you keep going. At the end, you'll have A equals to 1, B equals to 1, C equals to 1. Then say wait for 10 nanoseconds and then wait. End process and architecture. So if you do not have this last wait, your simulation loops indefinitely. So this is the test bench.